On this question, we have an arithmetic sequence. A1 is 5, A2 is 9, A3 is 13, A4 is 17. And there are several questions we want. First off, what are A5, A6, and A7? Well, what's our common difference? 5 to 9 is up 4, 9 to 13 is up 4, 13 to 17 is up 4. So our common difference, D, is 4. Our recursion for this is the next term is 4 more than the previous term. So A sub 5 is 4 plus 17, 4 more than the previous term, which is 25. A sub 6 is 4 more than the previous term, 4 plus 25, which is 29. A sub 7 is 4 more than the previous term, 4 plus 29 is 33, etc. Do one more. A sub 8 is 4 plus the previous term, 4 plus 33 is 37. And we can go on forever doing this. Let's see what the next question is. Determine a formula that defines A sub n, the nth term of this. Well, what is A sub n? Our general rule is A sub n is you start with the first term. To go from the first to the nth term, we've got to take n minus 1 steps. How large is each step? Each step is the common difference. So our nth term here, A sub n, is our first term. A sub 1 is 5 plus n minus 1 common differences. What is our common difference here? What did we say? We said our common difference here is 4. So 5 plus n minus 1 times 4 will be our A sub n. And let's see what the next thing that asks. It says determine the value for the 50th number in the sequence. Okay. So what is A sub 50? To get from A sub 1 to A sub 50, I've got to take 49 steps. So I start with 5, my first term. I take 50 minus 1, 49 steps. Each step is size 4. What does that give me? 5 plus 49 times 4 gives me 201. And then what is asked? Find the value of k such that A sub k is 85. So 85 is over here. I want to solve for k. So A sub k would be 5 plus k minus 1 times 4. So let's see that. Right? A sub n is A sub 1 plus n minus 1 times d. So A sub k is, in our case, 5. A sub 1 is 5 plus k minus 1 times d. Our common difference here is 4. What did the question say? What was A sub k? We want to solve for k. The question said that A sub k was 85. Okay, so we can do that. So 85 equals 5 plus 4 times k minus 1. Subtracting 5 from both sides, 85 minus 580 equals 4 times k minus 1. Simple thing here would be to divide both sides by 4. 80 divided by 4 is 20 equals k minus 1. Then add 1 to both sides. 21 equals k. So indeed, if A sub k is 85, k is equal to 21. And then what does it ask us to do next? We want to add up all the numbers from 5 to 85. So let's take a look at that. Adding up all the numbers from 5 to 85 in sigma notation first. So we have 5 plus 9 plus 13 plus 17 plus dot, dot, dot plus 85. This is what we're working with. We want to go ahead and we want to express that in summation notation. Now we said that this was A sub 1, and this is A sub 2, and this is A sub 3, and this is A sub 4, and this is A sub 21, right? So we want k to go from what to what? K is going to go from 1 to 21. What is our usual strategy? Start with the first term plus n minus 1 times the common differences, except of course the number of steps we're dealing with here is k this time. A sub 1 plus n minus 1 common differences. Common difference here is what? Common difference here is 4. So we have this. We have the sum as k goes from 1 to 21 of 5 plus k minus 1 times 4. Notice if k is 1, that becomes 0. It's just 5. If k is 2, 2 minus 1 is 1 times 4 is 4 plus 5 is 9 plus k is 3. 3 minus 1 is 2. 2 times 4 is 8 plus 5 is 13, etc. And then when k gets to be 21, 21 minus 1 is 20 times 4 is 80 plus 5 is 85. So we've established it that way. Now, how do we add all those together? My favorite approach is to think about pairs. So we're starting with 5 plus 9 plus 13 plus dot, dot, dot. 85 is the last one. The one before that would be 4 fewer, so that would be 81. Before that would be 4 fewer, would be 77. Now there's 21 numbers in this list, but I want you to focus on the first and the last. Notice 5 plus 85 is 90. 9 plus 81 is 90. 13 plus 77 is 90. So pairs equal 90. How many pairs do I have? Well, I have 21 numbers in the list, so I don't have an even number. If I had 20 numbers, it'd be 10 pairs. But I have 21 divided by 2 pairs, or 10 and a half pairs. So right in the middle of this thing is going to be 45. But my answer is still the same. What is that sum going to equal? The sum as k goes from 1 to 21 of 5 plus k minus 1 times 4 is the number of pairs, which is 21 halves, times the value of each pair times 90, which gives me how much? 21 halves times 90 gives me 945. Now, of course, we're going to check this on the graphing calculator. So I'm going to feed this into the summation operator on the graphing calculator and see if I really get 945. So let's see what we get. To the graphing calculator we go. Again, math. 0 is summation. And what do I want? K, it's in alpha numeric mode. K goes from 1 to 21 of 5 plus k minus 1 times 4. 5 plus k alpha k minus 1 parentheses times 4. And we hope we get the same number we had on the paper, which was 945. And we do.